Hello, my name is Diego Terol, and I want to explain what I did for practice number 7. Practice number 7 focused on doing all 4 main practices we did along the semester. They were tensile tests, metallographic analysis, impact tests, and hardness tests. The pendulum impact test helps us determine the amount of energy a material can absorb when impacted with a strong enough force. The material I worked with was 1045 steel at 27 degrees Celsius. 1045 steel works and behaves in a ductile manner at this temperature, since it is above its transition temperature into a brittle material. As it was expected, the break of the material was a ductile break, since it remained attached to each other in a uniform manner. However, once I touched it, it broke easily. Should it have been at a lower temperature, it would have behaved in a brittle fashion. All different types of hardness tests work by a different manner. You have to make an indentation into the material by applying a load using an indenter, and you have to measure the size of the indentation. There are either Grinnell, Rockwell, or Vickers, which were the 3 main different tests we performed. However, because of the results obtained, we found that the material, or the results obtained from our 1045 steel, were a bit higher than the published results of this material and the way it behaves. From metallographic tests, we were able to determine the number of grains as well as the size of the grains of a specific material. The size of grains and their number help us determine the mechanical properties of said material and can help us determine its resistance to fracture. The various steps help us clean, sand, and attack chemically a sample in order to be able to observe the different grain compositions. These are the different grain size images we obtained in the microscope with the 100, 500, and 1000 times magnitude of magnification. A tensile mechanical test helps determine the resistance of a material against tension. A material, 1045 steel, behaves in a manner such as this. This graph helps us determine its various strengths, its yield strength, and its tensile strength, and its maximal breakage strength. The material I work with, 1045 steel, shows the following characteristics that we can see in the table. With this area, length, and various forces applied against this material, we were able to determine its yield strength and its tensile strength. When compared to published results, it showed that the resistance of this material was a bit higher than the results you can find online or on books. This final practice helped us do step by step all the different processes we did along the semester. We could go from the tensile to the metallographic to the impact tests and finally to the hardness tests. This way we were able to reinforce the knowledge we obtained throughout the semester.